In this lecture, we are going to discuss about the generating functions which are derived from the canonical transformation and the Poisson bracket. Assume that there is a transformation taking place from Qi Pi to capital Qi and capital Pi, and this is the old system and this is the new system, and from old system to new system, when there is moving, there is a canonical transformation taking place. Now if Lagrangian L is equal to, so in the old system it is q dot and t, while in the new system it is L dash of capital Q dot and t. And coming to the Hamiltonian, which is a function of q, p and t, while in the new system it is capital Q, capital P and t. Now the Lagrangian from Hamiltonian can be written as sum over I Qi dot Pi minus h, while Lagrangian L dash is equal to sum over I capital Qi dot capital Pi minus h. So here becomes h dash. Now we can write L dash is equal to L minus df by dt, which means df by dt is equal to L minus L dash. Now substituting this L and L dash here, what we are going to get is Qi dot Pi minus h, that is sum over Qi dot Pi minus h minus sum over I capital Qi dot capital P I minus h. So this gives us that df by dt is equal to sum over I Qi dot Pi minus capital Qi dot Pi minus, plus h dash minus h. So here this is h dash minus h. Okay, that's fine. So if you are writing f as a function of, now df by dt will be a function of qi capital Qi and t. This is an assumption that we are making, that the function f is a function of small q, capital Q and t. Now if so, then we can write df by dt is equal to sum over I dou f by dou qi into dou qi divided by dou t plus that's dqi by dt, right? dqi by dt plus dou f by dou q I into dqi by dt minus plus dou f by dou t. So yeah, partial derivative of f. Now this can be written as sum over I dou f by dou qi dot plus dou f by dou qi dot plus dou f by dou t. Now here we have one equation 1 and this can be written as equation 2. Now comparing equation 1 and equation 2, we get qi dot is here, this is qi dot, and which means pi is equal to dou f by dou qi, and here we have minus qi dot, so this is qi dot, and capital Pi is equal to dou f by dou qi, and the last term h dash minus h is dou f by dou t, and that we can write it as h dash minus h equal to dou f by dou t. So this is what is when the function, generating function, this f is nothing but generating function. Now when generating function, total time derivative of the generating function is added to the Lagrangian, the Lagrangian may change, but the Lagrangian equation of motion remains same, which means Lagrangian is invariant. Now these equations are called, this is, let us write A, B and C. So these equations are called canonical equation of motion. So this is called canonical equation of motion. So this is canonical equations of motion. Now similarly, let us understand different generating functions. These are generating functions. Now the first one, as we have discussed, f1, the generating function f1, which is a function of qi, capital Q and t. Then pi is equal to dou f1 by dou qi, and capital P. So what is missing here? Why do we go for small letter pi? Here we have small letter qi, so what is left is small letter pi. So pi is equal to dou f by dou qi, and on the second quantity, which is capital Qi, and what will be missing is capital Pi, that is equal to minus dou f1 by dou, so it is what is present, Qi. Okay, now Qi. So now you can remember this. What is missing? Missing you have to find out. So missing equal to whatever the missing quantity is. Qi means capital small letter pi is missing. Capital Qi means capital Pi is missing. Okay, so dou f, the generating function, by dou of present. What is present here? That is what present is Qi. Here it is Qi present. Here capital Qi is present. So capital Qi is also present here. So dou f by dou present, missing quantity is equal to dou f by dou present. Okay. Now second one, f1, let it be the f2, which is a function of f2 of pi, that is the small letter pi, then capital Qi. The first term we represent the initial coordinate system, the another is final coordinate system. Then we have t. Now let us write down what is present, missing is pi, means Qi is missing, so Qi will be equal to dou f by dou present. What is present? Dou pi. Okay, so dou f by dou pi. Now in the second case, what is missing? Capital Pi is missing, which is equal to dou f by dou present is dou Qi, and there it needs a minus sign. Now for the third case, f3, which is a function of f3 of let it be Qi, capital Pi and t. Now what is missing here? Qi is there, small letter pi is missing. Pi is equal to dou f by dou Qi. Alright, now we have capital Q missing, so capital Q is equal to dou f by dou pi. And now as a third, for the last case, we will write down here the fourth one, which is a function of f is f4, which is f4 of pi, small pi, capital Pi and t. Now we need pi, means Qi is what we need. Qi is equal to dou f by dou present, that is dou pi, and here we need minus sign, and capital Qi is equal to, we need capital Qi, that is dou f by dou pi. Now here on the second case, Qi pi, this is a negative quantity, so this is a negative quantity. Now please remember this, all Qi, small qi and capital Pi are negative. All small qi and capital Pi are negative. Right. Now applications of what we have learned so far in the previous generating functions, that is the first application or type 1 is generating function is given. Generating function is given and we are asked to find out the canonical transformation. Now first question is regarding the generating function f is equal to capital P tan small q. So this is the generating function which is a function of capital P and small q. Okay, so and obviously there would be t, so it's capital P, Q and T. Now we need, since capital P is present, we need capital Q, which is equal to dou F by dou P, and we also required small p, which is equal to uh, dou F by dou Q. Now so we know that small qi and capital Pi are negative, so here there is no small q and capital P, there is only capital Q and small p. So this dou F by dou P and dou F by dou Q. So Q is equal to tan Q and dou F by dou Q, dou P, right? Yeah, tan Q, and that is Q is equal to tan Q and small p is equal to dou F by dou Q. So P sec square Q, tan theta derivative sec square theta, so sec square Q. Yeah, so sec square Q is given. So now we need to write in terms of capital P and capital Q here. So capital Q is equal to tan Q, and capital P, so from here capital P will be equal to P by sec square Q, which is equal to P cos square Q, so P cos square Q. So this is because we have the transformation Q comma P, small q and small p, and there is canonical transformation occurring, and we are getting capital Q and capital P. So this is what we are looking into. So we need to find out capital Q and capital P in terms of small q and small p through this generating function. As a practice work, you can also work on second f is equal to small q e to the power capital Q. So this is f1. Third question, lambda f is equal to lambda q square cot q, right? And the fourth question, minus half capital Q squared tan 2 small p. So this is what is given. Here we have type 2 application. Here what is given is canonical transformation is given. So transformation is given and we are asked to find generating function. So let's start with so here also the formula will be same, miss whatever we are going to miss here, that is nothing but dou f by dou present. And one more thing we have to remember, that is small qi and capital Pi are negative. Now as a question, we will start with capital Q equal to small p inverse and capital P equal to QP squared. So we are asked to find out the generating function in terms of capital small q, capital Q, and or generally we need to find out generating function in terms of q and small q and capital Q. Now we need f of small q, capital Q. So this is the question. Now for that we need the miss is equal to dou f by dou present. So miss is what is missing, small p is missing, that is equal to dou f by dou present is dou q, and this is positive, and small q is missing, sorry, capital P is missing. So capital P is equal to dou f by dou capital Q and with a minus sign because capital P is negative. So dou f by dou Q and from here we need to find out what is f. So take the first case, dou f is equal to P dou Q, or we can write df is equal to P dq, and f is equal to integral P dq, and integral P dq, and what is P? P is equal to 1 by Q, 1 by capital Q. Okay, so it's equal to 1 by capital Q dq integral, so that's equal to Q by capital Q. So f is given as small q by capital Q. Now similarly from this we can also find f is equal to capital P dq integral with a minus sign. So from here P we have, so P we need not change, yeah, P QP squared dq, yeah, so Q times P square dq, dq, yeah, so dq integral, and what is this P square? P square is, that is P square is 1 by Q square, so that gives us integral Q divided by Q squared, so there is a minus sign here, Q divided by Q square dq capital Q, okay, with a minus sign. So minus Q, this becomes minus Q 1 by Q square dq, that is nothing but minus 1 by Q, so that gives us Q by capital Q. So f is equal to generating function f is equal to small q by capital Q. So this is just for checking, we just need to check only one of the generating function, either go with this function or go with this one, both will give you the same answer. So in you need to go through only one of the methods, I mean one of the integration in the exam. And now you look at this, we are finding f in terms of small q and capital Q. So we got f in terms of small q and capital Q. You can also find f in terms of small p and capital P, f in terms of q, small q and capital P. So you can make the combinations and try to get the generating function f. As practice work, we can write Second question, q is equal to q squared and capital P is equal to small p divided by 2q. Okay, now we need to find out the generating function as a function of f of small q and capital P. Okay, now third question, q is equal to root q cos 2 capital Q and P is equal to root q sine 2p. Asked to find out f of small p capital Q. Here application is type 3 application where old Hamiltonian is given. Old Hamiltonian is given and we are asked to find out the new Hamiltonian. According to formula, that new Hamiltonian is nothing but h dash, the old Hamiltonian is h. So we know h is equal to h of q, p and t, and h dash is equal to h dash of capital Q, capital P and t. Now some simple example, and what is the formula that we need to use? H dash minus h is equal to dou f by dou t, and we have the old Hamiltonian h of h is equal to h of qp is equal to p square divided by 2m plus half m omega square q squared. F is equal to minus q by q, and find h dash. See, we have the old Hamiltonian given, the generating function f is given, and we are asked to find out after this generating function acting on this old Hamiltonian, how we are able to achieve h dash. So since there is no change in h dash, we are writing h dash is equal to p square divided by 2m, that is small p square. There is no change because it is invariant, half m omega square q squared. Now we have the generating function f given by capital minus capital Q by small q, and let's find out what is small p. That is equal to dou f by small p. P means small q, that's equal to q by q square. Minus and minus get cancelled, and now f is there. We have found out small p. Similarly, we can find out capital P, which is equal to minus dou f by dou capital Q, that's equal to minus of minus plus 1 by small q. So capital P is equal to 1 by small q and small p equal to capital Q by q square. So capital Q, here we got capital P 1 by q, and from this equation we are writing capital Q is equal to small p q squared. So this two we have achieved. Now once again we will write h dash, which is equal to small p square by 2m plus half m omega squared q squared. Now p square, so we need to write what is capital P squared. So p square will be equal to q square by q q square. So yeah, small p we need, and now we have p squared. So from here p square we have here small p, from here small p is equal to capital Q by q square. So let us write down here small p is equal to capital Q divided by q squared. Now we need capital Q here, so bring this capital Q from here, so pq square, so that becomes so now we have here q square from here in this equation 1 by q square, so it becomes p squared, so that's equal to qp squared. So small p is equal to qp squared, so this becomes p square becomes q square p power 4 by 2m plus half m omega square. Now we need q square. Q square is nothing but from here q square will be nothing but 1 by p square, so it will be 1 by capital P square. So this is the new Hamilton H dash. For practice work, you can consider doing this question. Small p squared by 2 alpha small q squared plus beta by 4 q power 4. The f is equal to q square capital P, and you are asked to find out H dash. Oh, sorry, it's not the H dash. You are asked to find here the generating function f of p comma